What we want to do in this series of lessons is learn how to expand brackets of the sort x plus y to the power of n. The reason we call it the binomial theorem is because the bracket has two terms. Now, if we consider a nice simple bracket, x plus y to the power of 2, we know what to do with that. X plus y, x plus y. So expand, we get x squared plus xy plus xy plus y squared. And that simplifies to give this. Now what I'd like to do is just to emphasize the coefficients. These numbers here. That's what we call the binomial coefficients. If we consider the bracket x plus y to the power of 3, what we get is 1x cubed plus 3x squared y. Notice as well when I'm writing this out that the power of x is diminishing by 1 with each term, and the power of y is increasing by 1. Now in this term here we don't appear to have a y, but we could write that as y to the power of 0. So 1x cubed plus 3x squared y plus 3, so the x power is going to diminish by 1, that gives us x to the power of 1, and the power of y will increase by 1, and the final term is 1y to the power of 3. So again, here are the binomial coefficients, 1, 3, 3, 1. I'm going to do one last one, x plus y to the power of 4. So that's 1x to the power of 4, 4x to the power of 3, increase the power of y by 1, so that'll be y to the 1, and then it's 6x squared y squared plus 4, reduce the power of x by 1, increase the power of y by 1, and then finally 1y to the power of 4. Again, here are the binomial coefficients. What I want to do now is just to look at the binomial coefficients. So we had the bracket x plus y to the power of 2, that gave us the coefficients 1, 2, 1. We had the bracket x plus y to the power of 3, that gave us the coefficients 1, 3, 3, 1. X plus y to the power of 4, we have the coefficients 1, 4, 6, 4, 1. I'm going to add a bracket up here. We don't often see that. X plus y to the power of 1. Well, if we expand x plus y to the power of 1, we just get 1x plus 1y. What we have here is a part of Pascal's triangle, which you may have seen before, and that's just an ordered presentation of the binomial coefficients in triangular array. Now the triangle is lacking an apex, a number up here, that's 1. Notice that we have a 1 at the start and a 1 at the finish of every line. Also notice as well that if it's a bracket to the power of 2 that we're expanding, then the second term in the line will be a 2. If the bracket has a power of 3, then the second term in the line will be 3. Also notice that if we add the two terms above, so 1 plus 1 will give us a 2, 1 plus 2 will give us a 3. 3 plus 3 will give us a 6, and so on. Notice as well that the numbers are symmetric. So we have a 1 and a 3 starting this row, and we have a 3 and a 1 finishing the row. There is a way of finding the binomial coefficients, and it looks like this here. And we express that as n choose r. And that can be written as n factorial over r factorial n minus r factorial. And on the calculator, that appears as n c r. Now the factorial function is n minus 1, n minus 2, so on and so forth. So 5 factorial is 5 times 4 times 3 times 2 times 1. 1 factorial is 1, and 0 factorial is also 1 as well. Now this comes from a section of mathematics called combinatorics. I'm not going to go into that just now. We may go into it later in just a wee bit of detail, but it's sufficient to know that this formula gives us the binomial coefficients, the ones that appear in Pascal's triangle. So let's consider the last line of Pascal's triangle that we wrote in. It was for x plus y to the power of 4, and the coefficients were 1, 4, 6, 4 and 1. So this is 4 choose 0. This is 4 choose 1. This is 4 choose 2. And this is 4 choose 3. And this last term is 4 choose 4. That's how we say that. Let's take this one here. So 4 choose 3. Well, the formula tells us it's 4 factorial over 3 factorial, 4 minus 3 factorial. So that's 4 times 3 times 2 times 1, 3 times 2 times 1, 4 take away 3 is 1, and 1 factorial is 1. Now, we can cancel. The bottom line is 3 times 2 times 1 times 1. These numbers cancel from the top and the bottom. 4 over 1 is just 4, which is what we have here. You could try that on your calculator as well using the NCR button. So if you're going to use that on the calculator, you would put in the 4 first of all, then it would be NCR, N choose R, and then put in the number 3. That's much quicker than doing it this way. So 1 or 2 examples using this formula. Example 1. What about 6 choose 2? Work out that value. So that's 6 factorial over 2 factorial, 6 minus 2 factorial. So I'm going to write all these out. 2 factorial is 2 times 1. And 4, so 6 take away 2 is 4, that's 4 factorial, 4 times 3 times 2 times 1. Now you can probably see that we've got these numbers here. That makes up 4 factorial, 4 times 3 times 2 times 1. So those will cancel. 6 times 5 is 30. 2 times 1 is 2. That gives me 15. So it's useful that you can do this, but you also want to be able to use the calculator. And you can check using your calculator. That's 6 choose 2 gives us the value of 15. Example 2. What about a problem of this sort taken from the textbook? So we've got n choose 2 equals 120. We want to find the value of n. Well, we know the formula. So n choose 2 can be written as n factorial over 2 factorial n minus 2 factorial. Now, n factorial, that's n times n minus 1 times, now it's multiplied by n minus 2 factorial, but let me just explain what's going on here. So I'll continue this for a few terms. What have we got on the bottom line? We've got 2 times 1, which is 2, and then we've got n minus 2 factorial, so we're starting with n minus 2, and then that's multiplied by n minus 3, n minus 4, etc. And you can see that these terms here cancel it with all of these terms here. So we now have, don't want an equals there, we now have n minus 1 over 2 equals 120. So that's a problem that has to be solved. Multiply by 2, expand the bracket, so we've got n squared minus n equals 240. N squared minus n minus 240 equals 0. This will factorise to give us 21 and 20. We want a minus 1, so we'll have the minus here, and that gives us two values of n. And we're only interested in the positive value. So n equals 21. That's how we would solve a problem of that sort. Here's a nice simple one from the textbook. So n choose 3 equals 4. Find the value of n. Well, that's n factorial over 3 factorial n minus 3 factorial, which equals 4. So that's n minus 1, n minus 2, n minus 3, 3 factorial is 3 times 2 times 1, and n minus 3 factorial is n minus 3, n minus 4, etc. And that equals 4. So what do we have? Well, n minus 3 factorial, so these terms here are going to cancel. And we've got something on the top that needs to be expanded, so that's n minus 1 times n minus 2, and that's a 6 on the bottom, and that equals 4. So if I multiply by 6 I get 24, and what do I have here? I have n, if I expand the two brackets I have n squared minus 3n plus 2, and I then have n cubed minus 3n squared plus 2n, and I'm going to take the 24 over and write it like so. So that's what we've got. That's a cubic function which we have to solve, and we're going to do that. I hope you remember you work on polynomials from S5, so we're going to have to find the factors of 24. That'll be plus and minus 1, plus and minus 2, plus and minus 3, and there are one or two others, plus and minus 4, plus and minus 6, and plus and minus 8, and plus and minus 12, and plus and minus 24. Which of those numbers, if we substitute in to this equation, will give us a 0? So n cubed, n squared, n to the power of 1 and n to the power of 0, remember your table. So 1 minus 3, 2 and minus 24. And then 1. So what we want is a remainder of 0 in this position here. So I'm going to try, I'm not going to work through all of them, that's something that you can do. I'm going to try the number 4. So 1 times 4 is 4, minus 3 plus 4 is 1, 1 times 4 is 4, 2 plus 4 is 6, 6 times 4 is 24, 24 plus minus 24 equals 0, and that means that x minus 4 is a factor. So we've got, or rather, not x, but let's just change that to an n. So we have n minus 4 as the first factor, and then we have the quotient, that gives us n squared plus n plus 6, and that in fact doesn't factorise. So we've only got the one factor. That being the case, n minus 4 equals 0, and n has the value 4. Before I look at example 4, what I'd like to do is to write out the coefficients for x plus y to the power of 4 again. So that's 1, 4, 6, 4 and 1. You'll notice that these two are the same, and that is, we write that as 4 choose 1, and this one here is 4 choose 3. Now, what we want to do is to try and relate those. I hope you can see that this one can also be written as 4 choose 4 minus 3. 4 take away 3 is 1. Now, if we write that in a general form, so n, let's start with this one over here. So that would be n, choose r, and that's the same as n, choose n minus r. That's something that you might want to write down in your notebook. So when it comes to doing a problem of this sort, n, choose n minus 2 equals 15. We need to work out the value of n. Well, the formula that we've just written down is that n choose n minus r gives us exactly the same coefficient as n choose r. That makes our problem a good deal easier. So what we can do then is rewrite that as n choose 2 equals 15. So that's n factorial over 2 factorial n minus 2 factorial equals 15. So we've got n minus 1, n minus 2, that's 2 times 1 is 2, then we've got n minus 2, n minus 3, equals 15. These terms cancel, and that leaves, expanding the top line, we have n squared minus n over 2 equals 15. And if we multiply by 2, we have n squared minus n equals 30, and I'll bring the 30 over. We can then factorise, and that gives us n and 5 and 6. I think I've already done this one. It gives us n equals 6. So this formula here is useful. So the binomial coefficients for x plus y cubed are 1, 3, 3 and 1. And for x plus y to the power of 4, we have 1. Now remember what I said, we can find the second number by adding those two, and the next term by adding those two, the next term by adding those two, and then there'll be a 1 at the end. Now, this here is, that's 4, choose 1. This here is 3, choose 0. And this one here is 3, choose 1. What we can say then is that 3, choose 0, this is a specific example on which we're going to draw a formula. 3, choose 0 plus 3, choose 1 equals 4, choose 1. Now, if we write this one here as n, choose r, how are these two connected? Well, we're going to have n on the top. So we've got 3 here and 4 over on the right hand side, so that'll be n plus 1. We've got 1 on the bottom, 1 on the bottom. That's going to be r there. And how do we get a 0 from a 1? We take away 1, so that's going to be r minus 1. That's a general formula that we can use. That's something that you need to note down. So there it is there. Here's the line that we're interested in. Last example, for what values of a and b is 8 choose 2 plus 8 choose 3 equal to a choose b? Well, what we have here is the combination. So that's n choose r, and this is n choose r minus 1, and that gives us n plus 1 choose r. So if n has the value 8 and r has the value 3, considering this one here, then it means that we have, so we have 8 on the top, and you'll have n plus 1, which is 9, and 3 on the bottom. So a then has the value 9 and b has the value 3.